Hello students, and welcome to Mr. Barker's chocolate math lesson. Now you might remember we did this in class with our Hershey bars. And we're using this to learn fractions, and how about how fractions can have a different bottom, a different denominator, but as long as the top and the bottom can be matched up to the top and the bottom of another fraction by multiplying by 1, as we remember, whenever we multiply by 1, it never ever changes the number we're multiplying. So you can multiply 4 by 1, and you're always going to get a 4 on the other end, remember? So this applies the same way to fractions where in the top and the bottom of the fraction are the same number. It's the same as multiplying by 1. So we've got the, oh, excuse me, my pen's messing up. Ooh. We have the fraction 3/4. We want to change that. We want to change it so that it has 12 segments like the Hershey's chocolate bar. Well, in order to do that, we think, what can I multiply by 4 to get the bottom of this fraction to be 12? Well, we should know by our times tables that 4 times 3 equals 12. So we're going to multiply this by 3 over 3, which is the same as multiplying by 1. That's why we can do this. So we multiply 3 times 3. We know that is 9. And look, sure enough, 4 times 3 is 12. So that 3/4 is the same thing as 9/12. Let's see if it works with our chocolate bar. We can use our visual aid to prove that what we just discovered together is true. So here we've got a chocolate bar, Hershey's chocolate bar. It's just a regular one. We're going to open it up. I know you guys get really excited when you do this. Oh my gosh, we're opening a chocolate bar. So we're going to peel that back down like that, and we're going to pull it out. Oh, I broke it already. You know what? It's a good thing Mr. Barker brought a spare. We can use that for another example later on. It'll work. All right, we'll try again. That's okay. Remember what I say, kids. If making a mistake, no big deal. We just keep rolling. We don't get bogged down with it. All right, so I'm going to open up this chocolate bar, and this time I'm going to try very hard not to break it. Now, the funny thing is chocolate bars are designed to be broken. But for this case, we want our chocolate bar intact so that we can discover the amazing fraction hidden inside. Okay, I got it. So here we go. And I'm going to use a paper towel so it doesn't completely melt on my hands. So you can see here, we've got a chocolate bar. And hopefully you can see. Let me actually turn an extra light on. That'll help you out. All right, there we go. Hopefully that isn't too bright. But as you can see, we've got 12 sections. 1, 2, 3, 4. And we do that again. 8. We do that again. 12. There are 12 sections. So our chocolate bar right now, because it's one chocolate bar, it's going to be written as the fraction 12 over 12. So we know that's our chocolate bar, 12 over 12, because it's got 12 sections. But we don't have to break off each individual section, do we? We can break it off into bigger chunks. So what we're going to do right now is we're going to take off a fourth of chocolate bar. Now, how do we know it's a fourth? Well, that's the tricky part. But if we count these rows of 3, we can see there's 1, 2, 3, 4 rows of 3 each. That's 4 sections. So we're going to break off one section. There we go. You see how we can lay this section over this 3 times? This is 1/4 chocolate bar. And this is the number we talked about at the beginning, 3/4. 3/4. So, now, remember we multiplied 3/4 by 3 over 3, and we got 9/12. Well, let's see if we were right. So we had 3/4 equals, oops, didn't write that very well, 9/12. All right, everybody see? Good. All right. So 3/4 equals 9/12. Now remember, the little sections in a candy bar, those are twelfths. So let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. So here I have 3/4 of a Hershey's chocolate bar, but it can also be 9/12. And guess what? Imagine each of these little sections was cut in half. We would then have, well, let's find out how many we'd have. Instead of me just telling you, let's show you. To double the amount of sections, we're going to multiply by 2/2. Oh, gee. What did I do with that? Oh, there it is. So we've got 9/12. We want to double that. Say we wanted to cut each little section in two. Well, we're going to multiply by 2/2, which is the same as multiplying by 1. 9 times 2 is 18. I can write it down here so it's easier to see. 9 times 2 is 18, and 12 times 2 is 24. Same thing, right? 18/24. Same thing as 9/12. Same thing as 3/4. We're just multiplying by different versions of the number 1. Now, finally, let's take a look. Let's see if we can do it the other way. Let's do the reverse. Let's try to start with a large number of segments and try to come down to the smallest number possible. Because the smaller the number of segments, the easier it is to say and to think about. So, remember that chocolate bar that I broke on accident at the beginning? We're going to use that. Here we go. Okay. There's the one I broke early on. Like that. We broke it right in what? That's in half, right? So let's look. What's each segment have? Well, let's count the number of little segments. We got 1, 2, 3, 4, 5, 6. And what are they? What is the total number? It's 12, right? So that is the fraction. Oops, got stuff on my hands. 6/12. We need to find out the smallest way to write this. Well, in order to do that, we need to do the opposite. We need to divide. So, we are going to, hang on one second. Remember how we studied greatest common factors? That's the word I was looking for. That's what we're looking for. We want to find the greatest common factor between 6 and 12. So, those are even numbers. We know 2 goes into that. So, we can cut each of those in half if we want to. That would give us, we take 2 out of there, and that's going to be a 3, right? Because 3 times 2 would be 6, and then we take a 3 out of here, or excuse me, we take a 2 out of here, and we'd have a 6. But an even easier way to do that is to know the greatest common factor, like I said. The greatest common factor, we all know that 2 times 6 is 12, right? So if we take a 6 out of there, what we're going to end up with is what times 6 equals 6? 1. So we're going to have a 1 up here. And what times 6 equals 12? 2. So if we were to keep pulling those factors out, we would end up with a 1/2. Let's see if that's right. So we're going to look at our candy bar, and we're going to pretend those little segments don't exist. How many pieces do I have of the whole candy bar? 1, 2. And how many is this of the 2 segments? This is 1, right? So 6/12 is the same as 1/2. Can we prove it? Of course we can. All we have to do is multiply by 1, just like we've always been doing. Remember how we took the 6 out? We're going to put it back in. 1/2 times 6/6, which is the same as 1, is equal 1 times 6 equals 6. And 2 times 6 equals 12. So 1/2 equals 6/12. This is really important to recognize because while it's cool to say 6/12 when you've got a candy bar, if you said that to your mom, if you said, "Mom, I want 6/12 of a cup of flour to help with my baking project," she'd go, 6/12? What? Well, the common term is 1/2, and it's important to recognize that these are the same thing. So that's all for our lesson today. I hope you enjoyed it, and enjoy your chocolate. It's good.